This video is about the structure of ionic compounds. So, as a whole, any ionic compound is referred to as a salt. And again, what an ionic compound comes from is a transfer of electrons from metals to nonmetals. And when that happens, they both obtain a stable octet. Okay, so we got that idea of what an ionic compound is. It is made up of ions. So I would have a metal ion, like sodium, with a positive charge, and I'd have a nonmetal ion, like chlorine, with a negative charge. And when they go together, it forms what's called an electrostatic attraction. So I would have an arrangement of positives and negatives repeating. So this is going to be a positive. Here we go for another negative. Then there would be a negative here, ion, and then a positive. And it just keeps repeating like that. Positive, negative, positive, negative, positive, negative. So that's called, so that bond is electrostatic in nature, meaning it's just the positive-negative interaction. Now, when we start talking about ionic compounds, there do happen to be three fundamental arrangements of ions in a crystal or a crystal lattice. And the first one, we're really not going to spend much time on what the shapes are because there's not a whole lot of interest in them. They're really pretty basic. This one that I'm drawing right now, I can't get that to show up. I'm not sure why that's doing that. So we'll make it a little smaller. Okay, where I have an atom at each side. This is called a simple cubic structure. So there would be one atom there, one atom there, one atom there, or ions. Ion there, ion there, ion there, and there. Okay, so this is a simple cubic crystal lattice. And if I look at the simplest repeating orientation of this, okay, that's called the unit cell. So this unit cell, because there's actually, coming back here, there'd be another ion there, kind of like that. This unit cell is going to have 8 atoms associated with it. So now the next one that I'm going to try to draw is going to look somewhat similar to the unit cell. Okay, I'm going to kind of get these all up here. Go there, 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 and coming down like that. All right, but this one has an added ion right smack dab in the middle. So there's still this one back here that goes up to there. Oops, didn't do a very good job on that. Let's try that again. Okay, so where are all my colors? How come? All right, so first let me get the basic simple cubic cell looking sort of like that. So again, I have those 8 ions at each corner, but then there also happens to be one smack dab in the middle. And this one is referred to as a body-centered. Cubic cell. All right. And then the last one. So this would the last packing that ionic compounds can have is, again, I have the basic unit cell, simple cubic, looking like this. I've got one back there, going up to there, and back to there. But this one, okay, so here are my 8 ions packed around like this. Okay, looks something like that. This is called a face-centered, and what a face-centered is going to do is it's going to have an atom or an ion on every face of the cube. So it's called a face-centered. And I'm not sure I drew the greatest picture of it, but face-centered cubic cell. So these are the 3 basic shapes that ionic compounds can take. And they're all sort of the same. They're going to result in what we would think of as a salt. Crystalline, granular structure, repeating ions, positive, negative, held together with electrostatic charges.